Hello, good afternoon, everyone. Hope you can hear me.
Good afternoon, sir.
Good
Okay,
afternoon, sir.
okay, thank you, Virang. So, I went through your answer scripts, and I'm happy that actually I gave you that unit test. Okay, there are a lot of things that I have to change in the way that I teach. I thought of while marking your answer scripts. I think. Most of you have tried almost all the questions, but the marks not that high. I think Dinush has done well. Dinush has scored 65 out of 65. Well done. But others too, I think like you understand what I say. But uh, you are unable to interpret it. That means use it when it is needed. So I will discuss some points that we need to address. Okay. And this, by the way, what is your DP? This picture? I haven't gone through this animation. What is in your DP? Hello,
Bruce?
Dinesh. Ah.
Yes.
Oh, what is the photo of your DP? Actually, I haven't been in, I have not seen that character before. In which movie or animation clip is it available? Oh, it's just a random picture.
It's in a game.
Game? Which game? Actually,
Uh, League of Legends.
a League of Legends. Okay, okay, okay. So if you are talking about games, I am a very good fan of games. Like in the university, I played like 3.5 years games, Call of Duty multiplayer. Okay, if any of you are playing COD for multiplayer version, okay. So I am a super fan. Actually, I wasted 3.5 years in my university life. So don't get addicted like that. And it was very fun. Okay. Recently, also I played the tournament. So they are good to have some fun, but don't get addicted. Okay, you will waste your time. And by the way, so what I thought was uh, uh, the way that taught you is a bit speedy. So I think of revising some things. So let's see on the way how to do it. I will discuss the uh, paper test paper with you at first, then I will hope to go with the move into the lesson again, and with the paper I will revise the things that we discussed. Okay, so actually I will tell you how I think when I see a question like this. So I think it will be most helpful for you to go through the same scenario. Okay, I think you all have the PDF with you. Do you all have it? Is it accessible to you all? I can share it in the screen as well if any of you need it.
Which PDF?
The unit test that we did yesterday.
Ah,
Okay, I attached it in the chat as well, so you can view through that as well. Okay, so I will go question by question. Uh, in the case you need to look at the board, actually you will most of the time need to view the board. So I think you are able to pin the shared screen and the table when it is needed. Is it clear? I think you are aware of that.
Yeah, clear.
that that's not a big deal for you. Okay. uh, okay, so what is the first question? What was it? Given the simultaneous equations, and they are asking us to show something. Okay, so at first, what what is a simultaneous equation? in simultaneous equations, what is happening? There are two unknowns. So to find one unknown, what we do? We eliminate the other unknown. Most of you have done the first question. That's okay. Okay. So we eliminate the first unknown. How to eliminate it? So look at here, x minus how much? 2y, no? X minus 2y equals 1. And the second one, 3xy minus y to the power 2 equals 8. Okay. So once you look at these given two equations and the part A, look at the part A, what they are asking. Show that they are asking us to show something. 5y to the power 2 plus 3y minus 8 equals 0. This is the thing that we have to show using these two equations. When you see this equation, which is in the part A, what you can see, is there any x here? No, x is not available in the asking equation. So you should think that we should think in our mind, x is not available here. That means in one of these, we have to eliminate x. By what? By substituting for x in terms of y. In the first one, what we can do? Easily, we can make the x as the subject. So what is happening? Take this 2y to the other side. How is it going to be? X equals 2y plus 1. Some have written this equation also wrong. Okay, the given equation, so that some of you have written equals 2. So get the correct data. That means when we are answering a question, what is the most important thing? Understanding the question and understanding the data. That means the starting of the question. Okay, if at the start of the paper you are getting the wrong data, that means the whole equation or the whole question is going to be wrong. So pay much attention when you are starting a question. Get the correct data. Always double check whether you are writing the same thing given they have given. Okay, that means if you are going to proceed with the wrong data, what is happening? Everything underneath goes wrong. Okay. Okay, so we can substitute x equals, that means for x, in the place of x, we can write 2y plus 1. So in the equation 2, what we can do? I take this as equation 1 and this as equation. Yeah, 2 and 1. Equation 2, we can substitute that value of x. See, in the place of x, I can write 3 times 2y plus 1 times y equals, not equals, y to the power 2 equals 8. Now quickly, now you should be able to make this quadratic equation into understandable format as soon as possible. So 3 into 2y 6y, again we have to multiply by y. So what is happening? 6y to the power 2. That means from this 3 and from this y, both things we have to multiply what is inside. And this is 3 into y, 3y minus y squared equals 8. Then what is happening? We can subtract y from the both sides. No, so what is happening? Not both sides, from here. So 5y to the power 2 plus 3y minus 8 equals 0. Okay. Okay, most of you have taken this one. After this step, it's better. That means some people have done using the equation. There is no wrong but you in using the equation, but I feel like it is a bit mechanical. That means if you are using the equation to find the answers for a quadratic equation, it feels like what, you lack the confidence in factorizing, because factorizing is the easiest way for these kind of, that means at the first glance you must be like within 30 seconds you must feel how is this factorizable or not. If it is not factorizable, it's better to go for the equation. Unless if it is factorizing, go for the factorization method. So If we are lacking that confidence, that means we have to do more and more questions on factorizing these simple equations. So I ask you again to do the questions in the chapter 2 and chapter 3 as well. We did some sort of factorizing. So do them again, okay? Because in maths, as I said earlier, what is going to happen? If we are going to skip and learn, is it successful? It is never going to be successful. Why? Why is that never going to be successful? These are going to repeat again and again. Okay, it's a never-ending process. That means uh, uh, we can't skip. It's like what is building? We are building a building. Without the first floors, can we build the second and third row? Four floors. It's not possible. They will collapse once it is in the. If we have not get the foundation clear. So basically in these first chapters, like from the first P1 book and the M1 book, mechanics 1 book, we have to be uh, very careful about these basic things. Okay, actually we have to master it. There is no other way. So what my request is, if you are not confident at factorizing these, go through the uh, chapter 2 and chapter 3 again. Find some questions on factorizing and do them. Okay, I will send find some and send you, so you do yourself. Invest some time on learning factorizing. Okay, so when we can we factorize this? Multiply these two. How much we are going to have? Minus 40 y to the power 2. So then what is happening? We have to make 3. How can we? The factors of 40 should have the difference should have to be 3. How can we make it? Easily we can see the same factors, no? But we can say 5y to the power 2 plus 8y minus 5y. 5 into 8 minus 5 into 8, we can have minus 40 this way. Okay, now what is going to happen? If we take 5y out, there is nothing else common. If we take y out, 5y plus 8, and here also we have to take minus 1 out. 5y plus 8 is equal to 0. So y minus 1 times 5y plus 8 is equal to 0. So how much? Y is equal to 1 and y is equal to minus 8 over 5. You can take them. So what is the logic here? Actually, why do we factorize? Why do we factorize to find the equations? There is a very important logic. Why do we factorize? We know when we multiply two numbers, think A and B are two numbers, and we take the result as 0. Okay, if two numbers are multiplied and then the result is 0, what we can say? Either A or B, one of these should be 0. Without any of these being 0, can there be the answer 0? It can't be, no? Think 5 times 4, how much? 20. Minus 8 times plus 3, how much? Minus 24. Any non-zero digits you multiply, you can't have a 0. Only when you multiply minus 5 into 0, you get 0. 8555 into 0, you get 0. That means at least one of these should be 0 to have a 0 as the answer. So then what we can conclude here? This is a very basic axiom we learn in like grade 8. If two numbers are multiplied, that means two unknown numbers are multiplied and we are having a 0 as the answer, then what we can say? At least one of these should be equal to 0. So in equations, we used this property. Here what we can say? At least y equals 1 should be y minus 1, or this part, or The first bracket should be equal to 0, the second bracket part should be equal to 0. Why? Two things multiplied, then answer equal to 0. So that's how we find y minus 1 equal to 0, 5y plus 8 should be equal to 0. Now we can solve this part. Y equals either 1 or y equals minus 8 divided by 5. Okay. So let's don't have these logics within you. If these logic parts are not there, we lack the sense of doing things. Why we are factorizing? That is also should be in our mind. Without that also we do mechanically, because we used to make hundreds of these and we just do factorize and actually don't know why we are factorizing. Okay, so get the idea why we are factorizing. Why we are factorizing is when two factors are equal to 0, then we can separately equal them to 0. That is why we make one side equal to 0 and factorize. Okay. So these are the two values for y. Using these two values, what we can do? We can find x easily. How? If we take this equation, how much is x? X equals 2 times when x is 1, 1 plus 1. So 3 plus 1, how much? 4. And when y equals minus 8 over 5, how much? So minus 16 divided by 5, good, plus 5 here, minus 11 over 5. So if you feel again uncomfortable when I am doing calculations like this in these fractions, that you have to be careful. That means there is some sort of lack of the basics. Again, what my request is, do some sums regarding these fractions. Okay. Okay. Question number was not that hard. Okay. But the question number 2, there are really important things that you should know. I am going to discuss them. So part A, actually in the part A, there was the fault with the many of you. Okay. Question number 2, part A. They're asking us to show something, no? In the part A, what is asking? 3 to the power x is equal to 9x minus 1. Is that 9y, no? Y minus 1. And they are asking, show that x equals to y minus 2. Most of you have figured out that write 9 as a power of 2, no? Sorry, power of 3. So we can write 9 as 3 to the power 2 and times y minus 1. Now what we can do? There is a mistake most of you have done. What is the mistake? Some of you have divided this by 3 and cancels off this 3. Okay, that is not possible. That means we can't divide like this. What is the theory behind this? At this place, what we can do is, we can't divide like by 3 here. What we can do here is, the bases, what is happening to the bases of the both sides now? The base is the same. This side also base 3, this side also base is 3. When the bases are equal, what we can do is equalize the powers. Okay. Before that, that means here power of a power. So what is happening, power of a power? If we write something like 3 to the power 8 times b, we can write this as 3 times ab. Here we can have 3 times 2y minus 2. Okay, now the base of the same side, both sides are same. Because of that feature, what we can do, we can equalize the powers. Okay, so what is the theory behind this again? When the bases are same, we can equalize the powers. The opposite also true. When the powers are also same, we can equalize the bases. Think this situation. When I would write 3 to the power x equals x sorry, x to the power 3 equals 5 to the power 3. Now what we can think? Both sides, it is the same power. Now what we can do? Equalize the base. That means x should be equal to 5. So these are the two theories we can interchangeably take. If the bases are equal, we can equalize the powers. If the powers equal, we can equalize the bases. But for this question, what we have to do is, since the bases equal, equalize in powers. Okay, grab that theory part. Okay, so always in any of the questions there is a little theory part hidden. So catching up this theory part is the most crucial thing. Okay, okay, after that what they are saying, for the second part it's just again a solving. No, you solve these two simultaneous equations. X equals to y minus 2, and what is the second one? X squared equals y squared plus 7. In the place of x, now we can write 2y minus 2. No, 2y minus 2 to the power 2 should be equal to y squared plus 7. If you remove the bracket, okay, some of you most of you have taken the power 2 of this in this writing in this format. Okay, that is okay. That means you have written the same thing repeating twice and get the multiplications and done the job. Okay, that is okay. But for the exam, I don't think it is enough, because in the exam, what is there is a fight with the time. For that, we should be quickly able to get the power 2 of this thing. How to do it? Try to grab this part also. What do we write? Square of the first term. That means 2y into 2y. What is going to come? 4y to the power 2. Then multiplication of the two terms 2 times. 2 times of the multiplication of two terms. That means when we multiply both of these, 2y into 2, 4. But this is plus, this is minus. So it is minus 4y. And that is also 2 times. That means minus 8y. And square of the second term, minus 2 to the power 2, that means plus 4, equals y to the power 2 plus 7. Okay, so what is going to come when we take y to the power 2 to the left side? We can have the equation 3y to the power 2 minus 8y minus 3 equals 0. After this point also, it is easy to factorize. It's not good. I don't recommend you to use in the equation to find the answer. It's correct if you use the even the equation, but that's not good thing to practice. Okay, try to factorize this. How to factorize? When we multiply 3y and minus 3, how much are we getting? We are getting 3y into minus 3, how much? 9y. No, minus 9y to the power 2. And by these factors of 9, we have to make 8. There are no lot of factors. You see, 9 times 1 or 3 times 3. We can feel that by 3 times 3 we can't make 8, but 9 times 1 we are able to make 8 here. How? Take minus 9y and plus y. So 3y to the power 2 minus 9y plus y minus 3 equals 0. Take 3y out. So what is going to remain here? Y minus 3. Here you can take plus 1 out. Y minus 3 equals 0. how much y times y minus 3 or 3y plus 1 equals 0. Now see, multiplication of two things is equal to 0. Now what we can say, either one of these should be equal to 0. That means y should be the equal to 3 or y should be equal to minus 1 over 3. Using these values for y, we can find the values for x. How much is x? X is equal to 2 times 3 minus 2, which gives us 4. Or again, y should be equal, sorry, x should be equal to 2 times minus 1 over 3 minus 2. Try to do these things in your mind. Minus 2 into 1, sorry, 2 into minus 1 minus 2. When we have a common denominator, this will be minus 6. So minus 2 minus 6 minus 8. Minus 8 divided by 3. Okay. Actually, I need your feedbacks. That means in the earlier days, Dinush gave the feedback. So I thought all of you in the same level. Uh, that means sometimes understanding is okay, but with the practice, it's going to lead. So if you have any questions or not clear, just ask them. Okay. Okay. Third question. Like many of you have not even tried it, because why? I also used to be the same when I was doing A levels. When I see something like K, then no, X and Y I can deal, but there is another unknown. I hate them. Why? It's hard. It looks hard. Okay. Actually, they are not hard, but it looks hard. So uh, I lack the confidence in trying them even. But later, when I deal again, when I was finding this again and again, I know that there is no escape. I have to deal with it. So then I accept the challenge and did like 100 200 questions, and what happened, they become natural. So that's the way to overcome these. Let's see the curve and the line is, they have given two equations again, no? That means two simultaneous equations. And they, what is it about k? K is an unzero constant. That means k is some value, but it is not equal to 0. That is the only thing they have taught. And they say intersect at a single point and find the value of k. Intersect at single point. That is the data. That means if you are not, once you read it, if nothing is coming into your mind, what should we think? Have to think? There is some point that I don't know where this theory is applicable. Okay. Okay. If we write any quadratic equation, and when we are finding roots, you might have learned about the discriminant, no? So what is the discriminant? That part, b squared minus 4ac part. What do we know about this discriminant? If this discriminant part is less than 0, what is going to happen? We are having a imaginary value or a complex value. That means we are getting this value under a square root, no? That means if we are, when we are finding the values for roots, x minus b plus or minus this thing, no? 2 times a. For this part, for the part which is inside the square root value, what we should have a positive value, because we don't know how to find the square roots for the negative values. Actually, we will learn a method in, I think, PO Maths part 3. Okay. About complex numbers. Until then, we are not dealing with what? This square roots of the negative values. That means this part, the discriminant part, should be always greater than or equal to 0. If it is less than 0, that means we are not having a real value. That means that equation is not having real roots. What happens? This is part is equal to 0. Then we tend to say this has only one root. And when this is larger than 0, what is happening? We tend to say this equation has two roots. So what is this relationship with the given question? They say intersect at two lines intersect at only one point. We discussed earlier when we are doing quadratic simultaneous equations that if two lines are crossing this delta x or the discriminant part, what is happening? It is again what? If it is delta x equal to 0, that means intersection is at one point. If delta x is greater than 0, that means this the line and a quadratic equation is cutting at 2 points. If it is less than 0, what is going to happen? The drawing line and the curve are not intercepting. Okay, they are not cutting at any place. So again, keep in mind this little theory part because this will come up. Okay, definitely I feel like this sort of a question is coming for the exam. So put this theory part into your mind. So the discriminant of which equation? Now that is a good question. What is the question? Discriminant of which equation should be greater than 0? That is the combined equations that we take by eliminating one unknown. Okay. Okay. So let's try to eliminate one unknown. All of you try. Try to have a equation with x over y only. Removing x over y. What is the easy one? I think removing y will be easy, no? Yes. So from the equation, the straight line equation, we can write what is there I have given? K over 2 times x plus y equals 1. When we take this part to the other side, y should be equal to k over 2x plus 1. What is going to happen? Now we can substitute this value for y in the equation y1 or the equation of the curve kx to the power 2 minus xy plus k plus 1 times x equals 1. Now what is happening? In the place of y, only y here, no? So we can easily substitute for y. See, kx to the power 2 minus x k over 2 times x plus 1 plus k plus 1 times x equals 1. Okay. When you are writing these equations in the paper, in your book, use the full space. Don't try to make questions. That means part A in the left side and part B in the right side. Don't try to save space. It's not going to help. Okay. Use space and write them clearly, very clearly. Now if you remove the bracket, you can see some terms are going to cancel off. So kx to the power 2 minus k over 2 x to the power 2 minus x. Here what you get? Kx plus x equals 1. Now what is happening? This minus x and plus x cancels off. This is what? K minus k over 2. If you take a common denominator, what is happening? It is plus k over 2 x to the power 2. No? And plus kx minus 1 equals 0. Now we get a quadratic equation here. What we can do here now? Now it's time to apply that theory part. What are they saying? The two lines are intersecting at only one point. That means the discriminant of this equation is equal to 0. What is the discriminant? What are the ABC here? A is k over 2, B is k, and C is minus 1. Using this equation, we can write what? K to the power 2 minus 4 times k over 2 times minus 1 should be equal to 0. Can write this now. If you solve it, what we are going to have? K squared minus 2k, not minus into minus, it becomes plus, equals 0. Now you can take k out as a factor, common factor. K plus 2 should be equal to 0. That means either k should be equal 0 or k equals minus 2. Now we get two values for k. Are these two values acceptable? No. In the data it is given k is a non-zero constant. So what is happening? We can't accept this. Why? It is given k is not equal to 0. So what is the only thing? K can be equal to minus 2. Okay. So for the part 1, we can take k equals minus 2. Okay. Chiranga, did you get it? Hello, Chiranga.
So I got that wrong in the.
No. That's okay. I asked that. Did you understand it now? What is happening?
Yes.
Okay.
Yeah.
So again, get the because this type of a question is most likely to come in a paper. Okay. So we have to, if you are not confident, what you have to do, like do this 2 3. This is the harder type. Actually, this is not harder, but we feel like they are harder. Once we know the theory behind it, it becomes very simple, no? So what is happening? What was our thinking procedure? There were x and y, two things, and they have given some data. No, there is k, which is a constant, and they intersect at one point. When we are solving quadratic simultaneous equations, we learn that what if the discriminant is, what is the nature of the discriminant? That means it is larger than 0, equal to 0, and less than 0. No? What is going to happen if it is less than 0? Those two lines are never going to cross. That means there are no points of intersections. You are not getting real values. But if they are crossing at one point, discriminant is equal to 0. And if the discriminant is larger than 0, that means there are two crossing points. They have given in the data, it's crossing at only one point. That means discriminant is equal to 0. So discriminant of which equation? That is also a good question. That means we have to form an equation by using these two. The discriminant of that equation is the what is going to be 0. So we formed the equation by eliminating y now, and we found the equation here. And we get two values for k, and one is not accepted because in the data it is said k is not equal to 0. So k is equal to minus 2. Okay, now try to do the part B of this one. Okay, I hope I'm not giving you an extra time to note this down. If you need, just ask me, because I hope you are also noting these things down when I am explaining. Okay. Is it okay, Nemita? That means, do I need to give you an extra time to note these things down? Nemita. k. So then we had k was equal to -2. And what was our equation? Actually, I can't remember. That is needed for the next part. No, we took k over 2 x to the power 2 plus kx minus 1 equals 0. No, if we substitute k equals -2 here, -2 over 2 x to the power 2 plus what was going to come, -2 times x minus 1 minus x squared minus 2x minus 1. Then what we get? X squared plus 2x plus 1. When you are seeing these kind of equations, you should be happy. We know what this is the x plus 1 to the power 2. So x should be equal to -1. Using this k and x, we can find y. How much is y? Minus k over 2 x plus y equals 1. We took y equals 1 plus k over 2 times x. So that means 1 time plus -2 over 2 into -1. How much we are getting? Y equals 2. So the point of intersection is going to be -1 comma 2. Okay, so Manut has joined. Manut, in your answer script, I think you forgot to attach all the photos. There was just one part of the question. Okay. Okay, let's see the question number 4. It was an easy one, but few of you have attempted. What is the 8? 8 divided by x to the power 2 plus 1 is less than or equal to 9 over x, and they say x is not equal to 0 as well. Okay. Now it's easy when x is not equal to 0. What we have to do? It's hard to what? Solve a quadratic inequality when there is a unknown in the denominator. So we have to remove it. What? By doing what? We can multiply all these terms by x to the power 2. Luckily it is available here. Think it was only like x here and x here. Can we just multiply by x only? No. We said that we don't know either x is negative or positive. Because of that, we have to multiply both sides by the x to the power 2. That means with the positive value. X to the power 2 is a positive value. If it was the case, you have to even multiply with the x to the power 2. But here, it's just multiplying by x to the power 2. What is going to happen? Now, in this side, we are getting 8 plus x to the power 2 should be less than or equal 9x. When you take everything to one side, you can have x to the power 2 minus 9x plus 8 is less than or equal to 0. So when we factorize, what are the factors we are going to have? We can have x minus 1 times x minus 8 is less than or equal 0. And then we learned draw this in a number line, no? When this part and this part is going to become 0, 1 and 8. If you think of a value less than 1, like 0, this is minus, this is also minus, minus into minus, this part is plus. In between, like 5, this is plus, this is minus, so it is going to be minus. And for this part, what is going to happen? 10, this is plus, so it is again plus. but it should be how much? Less than or equal to 0. What is going to happen? What should be? We can select only this part. That means x should be in between -1 or and 8, and they can be equal as well. Okay, so last question on the last question regarding the chapter 3. What is the question? They are given 4 lines and asking us to get the region. No? So how to draw it? This question most of you have tried. Okay, I'm happy about it. And some of you have, like 4 of you have got the correct answer as well. So what is the first thing what we have to do? We have to sketch. Okay, some of you have drawn the exact diagrams. That is okay, but it is a time waste. Why? They are not asking us the sketch, the exact diagram to the scale. We just need the intersection points. So when we are drawing a sketch, keep in mind what are the important points? Intersection points. Mainly the intersection point of y-axis, and if needed, intersection of the x-axis also better. So what is the first equation? Y plus x should be less than 6. What is going to happen here? Y plus x is less than 6. Drawing the equation when it is in this format, it's hard. Give me a second. Sorry about that. So when we have the equation, linear equation in this format, it's hard to think. Make y as the subject. So it's like y should be less than minus x plus 6. Now forget about this inequality sign. Now if it was a equal sign, what is going to come? Y equals minus x plus 6. Drawing this graph, we should be able to do quickly. What is the intersection point? 6. That means at somewhere here. And minus x. If it is like x plus 6, sorry, plus x plus 6, then equal the how much is the gradient? It is plus 1. That means with the angle of 45 degrees, y equals. If it is y minus x, 135 degrees with the x-axis. Or it is inclined in the other format. So we are going to have this kind of a graph. And if you are familiar with this, that means the gradient, you know that this point also going to be 6. Why? It has a gradient of minus 1. This is also should be the same intersection point for the x-axis. So this is 6 and this is 6. That is not needed. And from this graph, what we need? Less than that. That means our area should be in this area. Okay, should be here. if we are getting some values here, then y is greater than that. Then since it is less than, we have to take the dotted line. Okay, then what is the one they are talking? What is the inequality? Y is less than 2x plus 9 also. Let's try to draw that part. Y is less than 2x plus 9. What is going to happen if y equals 2x plus 9? 9 is going to be the point of intersection somewhere around here, and the gradient is positive. It has this way. If it is y equals x, it's going a 45-degree angle, but is it 2x? It has a high steep, like angle of how much? I would say 60, more than 60, 75 or something. Okay, it has a higher angle. Oops, never mind. Okay, this will have this kind of a graph because this is a sketch. That's okay. And it doesn't look like a higher angle, no? Okay. Like this. Then what is going to come? This should be, this is also less than. That means in this side should be the x values or the required area. Then y should be greater than 3 also. What is y equals 3? Y equals 3 line will be somewhere here. If it is greater than, that means to the upside of this. And again they say x should be also greater than 0. X equals 0 is the y axis. From this y axis, it should be in this side. So what is the area? This is the area. Okay, this little area is the area that is going to come for our answers. And they, for the part 2, they ask in the area of this part. If you observe the figure, what is the figure here? It's a right angle triangle. How to get the area of the right angle triangle? Half into base into perpendicular height, no? Base length. If we take this as the base length, how much is it going to be? You know, this is the y equals 3 line. Here, what will be the point of intersection? It is going to be the 3. If you solve like y equals 3 line and y equals minus x plus 6 line, you will have x equals 3. Okay, and this point is needed. And what is the length here? This is also 3 because 3 here, 6 here, so the difference is here is 3. So half times 3 times 3, 9 divided by 2, 4.5 square units. That will be the area of the shaded region. Okay. Is there any questions that you need to clarify? You can just ask. Okay, what happens if this was this, like that? Questions are welcome.
No questions.
Okay, thank you. Actually, what I wanted to discuss was more than this part was this last 3 questions. Okay, there are a lot of things. For the last 2 questions, I have to discuss a lot of things. Kinematics part. Okay. What is the question number 6? What do they say? A diver dives from a diving board into a swimming pool. That means what? There is a diving board. He jumps into a swimming pool with the height of how much? 4.5 meters. Okay, with the depth. The pool depth is 4.5. This will be the water, no? Okay. Then what? Then they say the height of the diver above the water is h. Above the water. Now get the point. Height above the water is h. If this is the diving board, this might be the who? The diver. Let's think this is the diver and this length is h. And what they say can be modeled using h equals, they have given an equation, no? H equals 10 minus 0.58 times x to the power 2. And what is x? They have given a range for x. X should be between 0 and 5. And they say x is the horizontal distance from the diving board. That means we think this is vertical and this is horizontal, x and y axis. X is from this point to this way. Okay. Okay. Find the height of the diver when x is 2 meters. That means when this person is, let's assume this person jumps. If he is a particle, what is going to happen? His projector will be like this, no? We can think different scenarios, like whether is he going to jump like this and coming back, but it is not needed to think like that. Why? Because this height is always going to come this way. Okay, even though you think like that, that is not wrong. It will not be effective for our questions. Okay, the answers. Let's just assume he has this kind of a jump. Okay. When you read this data, it's okay to draw a little sketch and note this thing down. Okay, if you are just reading, the data is not going to go into your mind. So what is the thing that we have to do when we are reading the data? Draw some sketch. Okay, draw a little sketch so that the data goes into our mind. Okay, now what is they are asking for the part A? They are asking find the height of the diver when x equals to. They are asking the height of the diver means what? How high he is from this water level. Okay, some of you have mixed it up with this depth, and some of you might have think this is the height of this person. It's not that. Okay, what you have to think is this person is just a particle. The height of this person is not to be considered, but how high he is from this water level, that is taken by this h. So what we have to just do, apply a value for x, the given value. How much? They are asking h, value of h when x equals 2. Even though if you look at this equation, you should feel like what? There are two unknowns, h and x. They are asking h when x equals 2. Grade 8 student can do this, no? How to? Just substitute in the place of x as 2. How much? H equals 10 minus 0.58 times 2 to the power 2. Some of you have taken this as this way, 0.58 to the power 2 into 2. Get these notations correct. This power 2 doesn't belong to this 0.58. If it belongs, it should be given with a bracket here. Okay, but it is given not with the bracket. So that means this power 2 belongs to x only. So those things you have to be very careful. Okay, little mistakes make up a huge, that means we fail to do the whole question. So when you solve this thing in the calculator, how much we are going to have? Minus 0.58 into 4. This will be how much? 2.32, no? 10 minus 2.32. 7.68 meters. This means the height of this person from the water level is how much? 7.68 meters. This is enough. No need to add it to the depth and again get the answer. Okay. What is the second one? Find the horizontal distance from the diving board to the point of where the diver enters the water. That means they are asking this length. When this person touch the water, long, how much distance he has been traveled. So you should have that what practical understanding as well when we are doing this type of questions. Why? That means if you think just he is just put in this manner, that is not going to happen. No, he has a what this kind of a projectile motion. It's not straight away down the place. So we take this length as x. How much? Uh, when he what hits the water, how much is the value of this height? It should be. That means uh, in the place of this h becomes 0, no? H equals how much? 10 minus 0.58 to the power x to the power 2. When he is at this level, this h should be equal to 0. And then how much? 0 should be equal 10 minus 0.58 times x to the power 2. You can make x to the power 2 the subject, then you get 10 divided by 0.58 and get the square root of both sides. You will have 4 point something. How much you got? Can any of you tell me the answer?
Which question is that?
Question number 5, B. How much is x here? Okay, someone solve this. I hope you are also just not listening. You do the questions with me, okay? While I am describing. Don't like just stare at this.
4.15.
4.15. Okay, so 4.15 meters. That will be the length. That means he touched the water in this much of a distance. Okay, what is the part C and D? They are also very important. These things, if you are not able to answer for part D, and those are free marks, like anybody can answer for those if you understand what they are doing. In this model, the diver is modeled as a particle, and what they are saying, describe the effects of this modeling assumption. What happens when we model this a person as a particle, and how is like his movement? He's flow, he is jumping through the air. If it is a point, what is going to happen? We know that when we jump in the air, there is some sort of a air resistance, but it is not a very high moment, no? So this air resistance is negligible. That means it is not need to be considered. So when he is jumping, or when we think him as a particle. Okay, so the we can say air resistance is negligible. And what are the other things? His rotational effects. Actually, when a diver is jumping, there are some rotational effects you might be learning in physics. Okay, and those rotational effects also not considered here. And what else? And the weight of this person is concentrated just to a point. Those are the three things that should come into our mind about this assumption. And what is D? Comment on the validity of this modeling assumption for the motion of the diver after she. There is she. No, I did not see that she. Okay, that means a lady diver. Okay, diver after she enters the water. What is going to happen? They ask is our the other assumptions of our are true when this lady is under the water. Can we think she as a particle? Is it good to think like that? No. Why? Because we can't think when we are jumping or going inside of the water, we feel a upthrust. No, that means there is a buoyancy effect. So this buoyancy effect and the resistance from the when we are going at a speedy, there is a resistance happening. So both the buoyancy and the resistance, they are in a considerable amount, so we can't neglect them. If we just think she as a particle, what is going to happen? Those effects will not be on the person, but in the practical scenario, those effects are highly considerable. Okay, but for the motion in the air, those effects are very less. That means you think when we jump from a little bit of height, is it the air resistance or these things affecting us? No. But when we are jumping into inside of the water, we can feel that our speed reduces, the water tries to pull up like that. So because of those two reasons, this assumption is not valid. Okay. Let's do question number 7. There are very important things, like most of you have to keep in mind when we are dealing with a question like this. Read the question number 7. Okay, when we are dealing with this motion question, there is a must do thing. What is the must do thing? We draw with little particle diagram, okay, including this data. I did not see that noting down this data in any of you. Dinesh has marked some of up to some extent. I think Sabri and Dinesh and some of you have done the question right. That means correctly, but you have not noted down the data. You are not getting the marks for noting down the data. But once you mark the data, what is going to happen? It is much understandable. Okay, what is the first thing that we have to do? Mark the data given in a little diagram, in a sketch. So what they say, two cars A and B. Think cars A and here it is B. And then what they are saying, moving in the same direction along a horizontal straight line. That means let's think they are moving in this way. And what else? Car A at the time t equals 0, they are side by side. That means they are at the same place. What is meant by this side by side thing? That means at the time of starting measuring time, they are in the same place. And what is happening? Car A travels at a constant speed of 30 meters per second. This car is traveling with a speed of 30 meters per second. And what is car B? Car B passes O with a speed of 20 meters per second. At this point, speed of 20 meters per second, and it is not enough. What they say, and has a constant acceleration of 4 meters per square second. And also this has a constant acceleration. Acceleration here. How much? 4 meters per square second. For A, he is in a constant velocity. That means this 30 meters per second is not changing, but him, what is happening? This speed is increasing. Why? He is in a accelerated mode. So what they are asking is speed of B when it has traveled 78 meters from O. Let's think this is the 78-meter point from this point of speed at here. Let's take that as VB, speed of V. Okay. And you have learned, I think you can remember the 5 equations. This should be in our mind. Okay. What are the motion equations? We know that V equals U plus AT. What else? What are the other ones? V squared equals U squared plus 2AS. Okay. What else? S equals, we can get S equals V plus U over 2 times T. What else? S equals ut plus half at squared. Or again we can have S equals ut minus half at squared. Sorry, not ut, vt. These equations should be in your mind. Okay. Actually, at least these three are the mostly used one. These three should be in mind. Okay, quickly you should be able to switch in between. What are the data? When we are considering this part A, they have given the distance. That means we know some S is equal to 78. What else we know? Initial, that means U we know 20. What else? We know the acceleration 4. What they are asking? Speed. That means V, final velocity when he is here. What is the equation that is having these 4 quantities? That is our question. How do we think? We can apply many equations and get it, but easiest way will be S, U, A and V. What is the one? The second one. V squared equals U squared plus 2AS. So we can write VB squared equals how much? U 2n to the power 2 plus 2 times A 4 times 78. How much are we going to have? I think it is 1024, no? VB. Take this by the calculator. And when you take the square root of the both sides, VB equals 32 meters per second. Okay. Okay, so why I selected this equation? That is the most important thing. I selected the equation V squared equals U squared plus 2AS. Why did I select that? I look at the data given for the part A. There is a distance, we know the starting velocity, we know the acceleration, and we need the final some sort of a velocity. This is the equation. That means if I put the other equations, there will be more unknowns. Okay, that's why I took this equation. What is the part B? The distance from O of when A when B is 70 meters, 78 meters. That means they are asking where is A when B is here. Let's think he might be somewhere here, and that length is SA, right? We'll write that as SA. Okay. When B is here, let's think A is here. How can we find it? What is the same thing? What is the data that we can take when B is here? That means the time taken for A to go to here should be the same the time that B has taken to come here. That thing we have to understand. What is the relationship? If we are not getting that point, going further is hard. That means it's not possible. But the relationship, according to the data given, we should understand that when B is here, what they say, they are saying at that time, how much time does the A has traveled? Or now we have to find the how much time does B has taken to come to this point. For that, we can use what? We can use the first equation, no? V equals U plus AT. Why? We know the V now. V equals U plus AT. How much? We took this value as 32. U 20 plus 4 times T. Now when we make T as the subject, we get T equals 32 minus 20 divided by 4. You will have how much? 3, no? 12 divided by 3 seconds. Again, learn the logic that I applied here. What is the logic? They are asking how far A has traveled. When? When B is at here. So we know that we have found the velocity or the speed of B here. How much? 32, no? 32 meters per second. And we can find how long does B has taken to come to this point, and using that time we can find how much A has traveled. Now how we can take the how much of a distance A has traveled? We can apply to this either one, this equation or this equation. Both the equations give us the same. I will apply to this equation. S equals ut plus half at squared. S equals ut plus half at squared. Okay. How much is the initial volume velocity of A? 30. T time taken is 3. And plus half time acceleration. What is the acceleration of A? It is in a constant speed. Is there any acceleration? No, it is 0. So we have to put 0 here. And 3 to the power 2. This is 90 here. This total part becomes 0, no? So 90 plus 0 equals 90 meters. Okay, it is a distance. Okay. Viranga, is it clear?
Yes.
Okay. That means when we are starting this, the start or the understanding is the most crucial part. Once we understand what is to do, it's just substitution and simplification. But to do that, we have to understand what is actually happening in this question. Okay. So again, step by step, think, why did I choose this equation? Why didn't I choose another equation? I could have used this same, but it's okay. Why you didn't I use this equation? Here is also s, but I did not use this one to find the distance a has traveled. Why? That since the acceleration is 0, this part is going to be 0. It makes no use for using that one. That's why I did not use that. Okay. So these things will come along the way, like how you have to do questions yourself. You will go wrong. Okay. You will go wrong again, go wrong, and then you understand, if this is the case, this will be the most likely outcomes. Like that, little by little, by practice, you know exactly what to apply. Okay. I can't teach you that, teach you to keep in mind when these are the data, use this, these are the data, use this. I can tell that, since I can easily know what is the data here. But to keep this to practice, what is the way? You have to, in your own, do these sums. You will go wrong, and then you will learn, and when these are the data, I must use this. Okay, because in some cases we can use two equations, like it's not the same one. But I am not going to say which is the easy one. Why? It should be come with your practice. Okay. Okay. Then part C, what they are asking, the time when B overtakes A. Time, yeah, the time. Let's think both are at this, when time equals t. Okay, time equals t, both at the same distance from here. Okay, now how long? So when these two are at this point, what is the data that we, the hidden data in between? We have to think. The distance traveled by A and the distance traveled by B should be the same. That thing should come into our mind. Okay. When they are meeting, that means when B is going to pass A, what is going to happen? The distance traveled by A and distance traveled by B should be the same. At that point, what is going to happen? That is the place where B overtakes A. Using that data, we can write another equation. What is the equation for the distance? We can use ut plus half at squared. When we apply this for the A, what we can get? That means we know that the distance traveled at this point A should be equal to distance traveled by B when they pass each other. Then we can have speed, the length traveled by A should be equal to ut. U is how much? 30. 30 times t plus this part becomes 0. Why? Acceleration of A is 0. This should be equal to how much? B's length how much? Ut. U is 20. 20 times t plus half times 4 times t to the power 2. At the same time, we don't need to use 2 t's. Why? At the same time, both of them take. So when you solve it and take the unknowns to one side, you get 2t to the power 2 minus 10t equals 0. Can divide both things by 2. 5t equals 0. T times t minus 5 equals 0. Either t equals 0 or t equals 5. Look here. Everything that at the t equals 0 also, what is going to happen? These two at the same point. And when t equals 5, again they are at the same point. So what is the time taken? We can't take 0y, that is the starting point. So when time is 5 seconds, both are at the same point. Now try to uh, draw these two motions in the same graph, motion of A and motion of B. Try yourself, graph this. Then you are going to understand many things if you do these kind of things without just rushing for the answer and not noting down. Now try to graph out the motion. Actually, I teach for the grade 10 of the UI school, and these type of questions are available for them as well. Okay, we did last day. So speed time graphs. So these type of questions, they are not using the equations but using the graph, using the gradient. We are finding times like this. Okay, the same type of questions with a graph. Okay, so for the motion of A, he is having like speed of 30 and he is traveling like this. What is the motion of B? He is starting with 20 and going like this. Now you should feel like when are these two people going to, this is B, this is A, when these two cars are going to pass one another? When is it this point? If you feel like this point, then you should have to learn many things again, right? This is the point where the two of these cars speed equal, not the distance traveled. Okay, from a speed time graph, how to take the distance travel? It's by the area. There might be a point where both of the areas of these are equal. This is the place t equals 5. 5 seconds. At the 5 seconds, they are. Okay. This will be 30, 20, and 0. These things you should understand. Okay. Graphing this part is not in the question, but you should feel. That means this has this kind of a graphical notation for the movement, velocity time graph. Okay. And time is up, but I am willing to discuss the part last question also, so we can move on to the lessons next day. Is it okay that I discuss that part also? It will take 10 to 15 minutes, or you want to, do you have some other stuff to do?
It's fine.
It's fine. Okay, thank you. Actually, Dinesh is the one who is giving the answers. He got everything, all of these correct. So it's like I feel like we need to do more questions for him, but I need the feedback from others as well. It's, don't worry that if you don't understand, okay, it's okay. That means we are doing this because we are not experts of this, to learn things. Give you a natural feedback, that's the best thing. I will tell you a story. uh, you know about Tesla, Elon Musk, no? I think you have heard about him. uh, he when he was, if you can go to YouTube and watch a lot of videos of him, is available. uh, you know that he started this electric car company. When he was building it, there were very harder times for him, like the things are not going to go well, sales are not there, their production line is breaking. There are a lot of changes come along the way. Most of the uh, car companies or any company owners, what they say when they are doing a company, oh, we are doing just fine, we are doing everything correct, we are going to do this thing like that. Most of the people are lying. But when Elon is in a struggle, what he says, I'm not, we are working hard, but we are in this struggle. We are in this period. We have to overcome this step. He was very honest. It means he says actual state when he is there. Okay. He says we are going to achieve this, but now we are at this current level. Unlike most of the other CEOs, he is telling the actual position where the company is. Okay. If you look at others videos, you will see this thing. Oh, we are doing just fine, there is no issues with us, we are on time, and this are bluffing. But that at the end, what happens? The person who says who is the honest one, he surpasses everyone, because he stands for his true self and expresses and work for it. That means to overcome this. So my request is, it's okay. That means when I was doing A-levels, I was so dumb. That means there were very little things I did not even understand. It's okay. But if you express that out, then a solution comes. But when we keep it to ourselves, what's happening? Solutions are not going to happen. Okay. Now the technology is advanced, so you can contact me personally and say, so can you discuss this part a little bit more? Okay, like that. Actually, Chiranga asked me that before the unit test also, it's good if we can discuss a bit on kinematics. That's why I'm doing this part. Okay, so like that you can uh, elaborate on things. Hello, so can you send me some exercises on factorizing? So then I will help you. Okay, but if that feedback is not coming, it's hard for me. That means we have not actually meet also in the school, so I don't know in which situation you are. Okay, that's fine. Let's move on to the last part. I will do it quickly. Okay. Question number 8. What they are saying? A train starts from rest and accelerates. Now, see, when I am reading this, I'm going to mark down, because I know at the end there will be a lot of this description and I don't remember anything. So little by little, one by one, I am going to note down. A train starts from rest. That means initial velocity is 0. That means we can think u is 0. Then what they say? And uniformly accelerates. It accelerates. It's going to accelerate by what? 3x, by 3x times 3x meters per square second, and until it reaches a velocity of 30 meters per second. Until it gets the velocity of how much? 30 meters per second. Then what is going to happen? For the next t seconds, train maintains its constant velocity. That means it goes like, let's see, from here to t seconds, it maintains the same velocity, 30 meters per second. Then what is going to happen? Then the train decelerates uniformly at x meters per square second. For that part, it is going to again decelerate x meters per square second and comes to rest at station B. At the B, what is going to happen? It is rest. The final velocity is going to be 0. The distance of the station is 6 kilometers. From A to B, how much? A to B is 6 kilometers. And what else? Time taken from A to B is how much? 5 minutes. T equals 5 minutes. Those are the data. So it takes some time to read the whole thing, but I have noted this time down. And now everything is in our mind. When you see the points, the motion is in our mind. Now, sketch velocity time graph. Velocity sketch. Again, we have to draw a sketch. Time axis, we have to draw a horizontal axis is time axis, and vertical axis is velocity. What is going to be? At the start, it is when t equals 0, what is going to happen? velocity is 0 and it accelerates until 30. There is acceleration. I just mark it as like this. What is this time? I don't know. What is this speed? I know. It is given. How much? 30. And for t seconds, it has the same speed. This is given in what? T. We found this as get data. We can take this as t. What else? Has a deceleration of 3 x. This is 3x. See, uh, I hope you know that the gradient of a velocity time graph gives us what? Acceleration. Those are very fundamental things. Okay, what is the theory? From the gradient of a velocity time graph, we can take the acceleration. So the acceleration here is 3x. What is the deceleration here? It is x. So the gradient or the slope of this line should be much smaller. So it will be like this. Okay, and come to rest. Okay, this is the sketch and we know the full time. So use same units. Don't you take minutes to this and this is to meters per second, then it will go wrong. Since we are taking meters per second here, we have to use seconds. How much is it here? It is 300, right? 5 minutes into 60 seconds, 300 seconds. At this point, it is 300 seconds. Okay, what the first thing? Show that 40 over x plus t equals 300. Look at the data and try to build it. That is the fastest way. Show that. We have to show something. 40 over x plus t equals 300. From where this 300 can come? It is the time. Okay. This is 300 is also a time. T is also time. Then we should get the feeling that 40 divided by x also should be what? It is the time. We can see that 300 can be taken by this time and these two times. They are not given. That means what? Using x, we should be able to find these two times. So then I take this time as t1 and this time as t2. Then we can see that what? T1 plus t plus t2 should be equal to 300. How can we get a relationship between t1 and x? That is our next problem. Again, I told you the theory. What is the theory? From the gradient of a velocity time graph, what we can take? The acceleration or the deceleration. For this part, what is the gradient? This length divided by this length. Okay. This height divided by this length. That means 3x should be equal to 30 divided by t1. If I make t1 as the subject, what is going to happen? T1 equals 30 over 3x, which gives us 10 over x. Now I get this part as 10 divided by x. Again, I can write for this part also. What is the difference? It is minus 30 divided by t2. So if I take that also, then I write to minus x. So I just write x equals how much? 30 over t2. When I make t2 as the subject, 30 over x. 30 over x is the t2 time 2. Now what? We can add these two now and take the values. How much? 10 over x plus t plus 30 over x equals 300. Now these are the two with the common denominator. So 40 over t equals 300. Easily we can get that, no? But thinking this part is crucial. Why? We have to understand that this 40 over x should be a time value. how I thought like that? I look at the other things. T is a time, 300 is also time. So that in to my mind it can that this can be the addition of this time and this time. Actually it was okay. Okay, then they ask him find the value of t and x. Now we have a combination or relationship between t and x, but that is not enough. Why? One equation, two unknowns. What else do we have? It is said that the total distance is also given to us. How much? 6 kilometers. Uh, from that, from this graph, we should be able to get the total distance travel. What is the theory? Area under the graph and the x-axis is the total distance travel. So what is the shape here? You can think this as two triangles and a rectangle, or you can consider this as a trapezium. It is easy. So how to get the area of this trapezium? I can write how much? Length of the two parallel sides. This is 300, this is t. So 300 plus t. Okay, so I think this part will be good for Sabri as well. Sabri has done this in another method, but using this method is easy. Okay, so 300 plus t divided by 2 times what? This height, how much? 30 equals how much? The total distance is 6. We can't write 6 here. Why? It is in kilometers. We have to substitute in meters. 6,000. And straight away we can find t, no? How much? This 0 and 0 cancel off. 3 and this becomes 200. When 2 goes this way, 300 plus t equals 400. Then we can have t equals 100 seconds. Okay. And using that, we can find substitute here and take how much? X. 40 over x plus 100 equals 300. So x becomes 40 divided by 200, which gives us 0.2 meters per square second. Okay, now actually in this speed time graphs, you should keep in your mind these theories. What are the theories going to repeat again and again? Gradient. From the gradient, using the gradient, we should be able to find the acceleration. That means relationship with the gradient of this graph and the area. Those are the two things again and again. Okay, this is the first time that we are doing this. This thing will be repeated 100 times, and I will tell it 100 times also. What? Gradients. From the gradient, I derived this one equation. From the area, I got another equation. So that thing will again you will have to do and do. So when you go through again speed time graph, you check whether did I use the area to find some relationship, did I use the gradient. For sure, if you are stuck, you have not used the data to derive some equation, the gradient and the area. Those two things are the mostly used two things. Okay, so now we found t and x as well. What else? Calculate the distance the train travels at constant velocity. Constant velocity. This part, no? We should know. We know that the area travel with the constant velocity we can take by area of this rectangular part. That means how much? 30 times tt is how much? 100. So 3000 meters, or you could write 3 kilometers. When you know the theory, these are very simple. So try to grab these theories. It doesn't come by speaking like a parrot. Area equals distance, area equal distance. It's not that way. You do calculations, go wrong, again get the theory like that. Okay, by the application, it goes into our mind. What do you see? Calculate the time taken from leaving it until the point halfway between the stations. That's a good question. Halfway between the station means how long? It means again 3000 kilometers. From the starting point, 3000 kilometers. Now we have to find how long will that point be. Let's think this will be the halfway point, and we know we have to find this time. How long does it takes to go this much of a distance? What can we do? Getting this time, this little time as t3. Okay, t1 we could find earlier using x. How much? For the t1 we got 10 over x. X was how much? 0.2. So you get 50 here. This length is how much? 50, and this little part I take is as t3. Now I can write the equation for the halfway length again using the area. What is the area? The total length should be 3000. So 3000 we can take by how much? This triangular part and this little part. Triangular part, how we can take? This length, it's a right angle triangle. Half into base into height. Half times base is 50, height is 30. Plus this time is t3 and height is 30. t3 times 30. How much we are going to have? Yeah, we are having 3000 minus 750 equals t3 times 30. And you divide both sides by 30. How much is t3? 225 divided by 3. We are having 75 seconds. So what is the total time? This 50 plus t3, that means 50 plus 75. We are going to have 125 seconds. Okay. This is how to get it. Okay, thank you for your support to discuss the total paper. And I think you might have revised the theories behind this. So when dealing with kinematics, drawing a little sketch is needed. Okay, that is the only way that all the data that goes to our mind. And for the person who is doing the marking, it's also visible that the student has taken these points. If you have not these things, if you don't note this down, that means data is not going to in your mind. I can clearly see it with your answers. When you have taken answers correctly, most cases, most of you have marked the data. Okay. For the people who have not marked the data, less marks. Why? He has lose some data. Okay. It is needed to know exactly where the data fits in also. Okay, so that's it for today, and let's try to continue from the lessons tomorrow. I will discuss more and more. The point that I'm doing more sums also in the same topic is what? To grab the little theory part. It's not to just be like a parrot to get the theory part. Okay, always try to get the theory behind what we are doing. That is the thing that is needed when we are dealing next time. Okay, so let's meet tomorrow. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.